Okay, the next thing that we want to talk about in this section is to see how we can predict the shape and the direction of a parabola from just by looking at the coefficient of your squared terms, coefficient of the x squared term. So how does that work? Let's go ahead and see what our principles are. So you have your quadratic function defined in this form, a times x minus h squared plus k, where a cannot equal 0. This one is just what we saw earlier, a parabola which will have a vertex at hk, and the vertical line will be x equals h, which will be your axis of symmetry. Okay, now this a is what will help us determine the shape and the direction of a parabola. So how does that work? It says if the graph opens up, that means that your a is positive, okay, and if a is negative, your graph will open down. So pretty easy to remember. If a is positive, it opens up. If a is negative, it opens down. So that's of course the direction of your parabola. And now for the shape of the parabola, it says if the value of a is between 0 and 1, and that's the absolute value. So even if a happens to be negative, you look at it in terms of the absolute value and see if the value is between 0 and 1, it means that your graph is going to be wider than that of the x squared graph, okay? And if the absolute value of a is greater than 1, then that means your graph is going to be narrower than our basic x squared graph. So again, if it's a is between 0 and 1, the graph is wider than x squared. If a is greater than 1, the graph is narrower than the x squared graph. So let's see if these things will help us out here. Now let's look at this function here. F of x equals negative 2 x squared minus 3. So you can see this term here is the coefficient on your squared term, negative 2. So they said if a was negative, if a is negative, your graph opens down. Okay, so this number is negative 2, the graph should open down. And the other thing they told us, if absolute value of a was greater than 1, absolute value of negative 2 we know is positive 2. Positive 2 is greater than 1. So that means the graph has to be narrower than our basic x squared graph. So open down and narrower than x squared. So let's verify that this is true. So we'll go ahead and graph this, and of course we'll come back and find our vertex, axis, domain, and range. We're going to do the same thing we have been doing so far. Start out with a t-chart, select some x and y coordinates, and then we'll use that to graph it. So let's say we'll go ahead and use our numbers that we like so much, 0, 1, negative 1, and we need a couple more, positive 2 and negative 2. Okay, so we'll take these numbers and plug that into our function definition here and find the y values. So 0 will give us negative 3, 1 will give us negative 2 minus 3, which is negative 5. Substitute in negative 1 for your x, and you should also end up with negative 5 on that. Substitute your x with 2, which will give you negative 8 minus 3, which is negative 11. And substitute negative 2, which will also give you negative 11. Okay, so we have 5 points here. That should be good to help us graph it. Now, since we know that our graph is going to open down, our coordinate plane, I have made it a little bit different because we are not going to have our graph that opens upwards, is going to open down. So I'm trying to save some space there, I suppose. Now let's go ahead and graph all of these 5 points. So you have 0, negative 3. 0, negative 3 would be right there. And I guess these will be 1, 3, 5, negative 1, negative 3, negative 5. Okay, our next point is 1, negative 5. So 1, -5 will be somewhere right here. -1, -5 will be a point right over here. Then you have 2 and -11. So let's see, that's -7, -9. We need to add another for our -11. There we go. Okay, 2 at -11 will be somewhere about here, and -2 at -11 will be somewhere about here. Okay, so once we go ahead and combine all of these points, this is what your graph should look like. So you can see it's a parabola that opens downward, and it is much narrower than our x squared graph. So if you have a graph of x squared in front of you, go ahead and compare it with that, and you will see that it is much narrower. The x squared graph should be more wider, and of course, it's going to open right side up. All right, now that we have our graph, let's go ahead and find our vertex, axis, domain, and range. So in this case, since your graph opens upside down, your vertex is now not going to be the lowest point, but the highest point. Because remember, when the graph is right side up, the vertex is the lowest point. Since we turn it upside down, it's going to be the highest point. So your vertex in this case is going to be at 0, -3, 0 on the x-axis, -3 on the y-axis. Your axis, again, it's the line that passes through the vertex, and you can see that's going to be the y-axis, which is x equals 0. Domain of this graph, again, if you imagine that if these arms keep growing, they will get wider as these numbers get larger, and so they're going to cover all the points on the x-axis. So your domain is going to be -infinity to +infinity. Now range, you will notice, is going to change quite a bit here, because your graph is at -3. There's no graph above -3. It's basically starting at -3 and it's going down to -infinity. But when you're working with negative numbers, you always put the smaller number first. So in this case, we would say our range is from -infinity all the way up to -3, and it stops at -3. Okay, so -infinity to -3, and we're of course including -3 in our set here. Okay, so you can see, since this is opening upside down, your range changes. Instead of going to +infinity, it's coming from -infinity and goes to -3 and stops right there, because there's no graph above -3. Okay, so you can see how the coefficient of your x squared term can help you determine what sort of graph you're going to have, what shape, what direction you can expect to see. Alrighty, now the next thing that we want to talk about is, just by looking at the graphs of the equations of our quadratic functions, we need to be able to determine what our vertices for each one of these functions are going to be. So let's look at our first example here. You have f of x equals -3x squared. Now again, remember, we had talked about this earlier, where we said if your graph is given to you in this form, you can identify what your vertex is going to be. Again, remember, when it's given to you as x minus h quantity squared plus k, your vertex is h, k, and your axis was x equals h. You want to try and use that same information here. So let's try and see if we can put this right here. Alright, so you can see that this one we're not adding any constant term, and x is not inside the parentheses with some other number. So this tells you this graph is going to have a vertex at the origin, just like x squared, and it's going to be the vertex 0, 0. Okay, there's no change happening here. Now looking at our second example, you have f of x equals x squared plus 4. So this is in the form x squared plus k. Okay, you're adding 4 to the whole quantity x squared. So that tells us your x value is going to be at 0, but your y value, this is a vertical shift example, means your y value is going to increase by 4 units because your graph will shift upwards by 4. So your vertex, of course, will change, and your vertex will be 0, 4. Looking at our next example, you have f of x equals x minus 1 and then the whole quantity squared. So this form is the example of a horizontal shift. And you can see that your sign in the middle is negative, which tells us that 1 is a positive number. And in this case, since it's a horizontal shift, your x coordinate moves by 1 unit to the right, because 1 is a positive number, which means your whole graph moves 1 unit to the right, and the y value stays at 0, okay, on the x-axis. And let's see, we have one more example. Right, let's say we have something of this form. Now this one you can see is very similar to our function here, f of x equals x minus h quantity squared plus k. Very similar, but except you will notice you have a minus sign here and you have a plus sign here. So what that means is that h itself is a negative number, and that's going to be negative 3. Because if you have a negative sign, it means h is positive. When you have a positive sign, it means h is negative, and this number is actually negative 3. So that's your horizontal shift. You have minus 4, and that is your vertical shift. So when you have negative 3 and negative 4, that means you're going to move 3 units to the left and 4 units down. Okay, so your horizontal shift will be to the left, vertical shift will go down. So you can see a lot of information is available when you look at the function definition in this form. Now we want to try and use the idea that we talked about earlier, looking at the coefficient of your x squared term, and try and decide if your graph is going to open up or down, and if it's going to be narrower or wider compared to the graph of x squared. Okay, so let's go ahead and look at our first example. You have f of x equals negative 2/5 x squared. So of course you can see negative 2/5 is the coefficient on your x squared term. It's negative, which means that your graph is going to open down. Okay, and 2/5, if you try and evaluate the value of 2/5, you will notice that this value is less than 1. It's going to be 0.4 if you convert this into decimals, and of course we know 0.4 is less than 1, so that tells us that this graph is going to be wider. Because remember, when the value is greater than 1, it's narrower. When it's between 0 and 1, the graph is wider. So negative means open down. 2/5, which is less than 1 and greater than 0, it means your graph is wider than the graph of the x squared function. Okay, so just by looking at the function definition, you should be able to determine that value. All right, how about this one here? Now you have f of x equals 3x squared plus 1 okay, So again, you're looking at the coefficient of the squared term, which is 3. It's a positive number, which tells us that it's going to open up, or open upwards. And 3, of course, is greater than 1 in value, so that tells us the graph is going to be narrower than the graph of our x squared function. Ready? We want to try and do a similar thing for the coefficients and the vertex that we just saw as examples separately. We're trying to combine them together in this example here. Now, your first A question is f of x equals x minus 4 quantity squared minus 2. So you have x minus 4 squared minus 2. Okay, not sure if you can see that. I'll go ahead and write that here for us. F of x equals x minus 4 squared minus 2. So if you're trying to identify the vertex, the vertex is going to be positive 4. Since that's a negative number, we know this number has to be positive, and this of course is negative 2, so your vertex is going to be 4, negative 2. Now you need a coefficient to try and decide if this is going to open up or is this going to open down. If you don't see any coefficient, it's understood that it's 1. Okay, so positive 1, it means if it's positive, it's going to open up. And yeah, it looks like we're not trying to decide if it's wider or narrower, so we're just trying to figure out what the vertex is and if it's going to open up or down. So your vertex is 4, negative 2, and it opens up. So it looks like your choice out of your given answers here is going to be number D. You can see the vertex is 4, negative 2, and it opens up. Okay, we're only trying to match each one of these quantities together. If you look at part B, it says f of x equals x minus 2 squared minus 4. Okay, so in this case, your vertex is going to be positive 2 minus 4. Okay, and again, your coefficient you don't have there, so it's understood it's a 1. Since it's a positive number, again, your graph opens up, and 2, negative 4 opens up. Looks like your choice here is going to be the number B. So in the same way, go ahead and figure out the matching answers for C and D, and you should end up with C as the answer for our third equation here, and A will be the choice for the last one. So in that same form, you want to go ahead and just match all your answers here. Just find what your vertex is using the coefficient in the front. If it's positive or negative, try and decide if it's going to open up or open down. Now for the last part of your section here, we are going to try and graph one more function. Now in this part, they're saying plot at least 2 points in addition to the vertex. So of course you need to identify your vertex and find 2 more points to help you graph that. And again, we need to identify the vertex, axis, domain, and range. So we'll look at just one example, and we'll try and use that same information about the coefficient of your x squared term and what your axis and vertex should be. So let's take a look at our example here. You have f of x equals 2, x minus 2 quantity squared minus 4. So of course you can see your leading coefficient is a positive 2. That tells you your graph is going to open up. 2 is greater in value than 1, so it's going to be a narrower graph. And you can identify your vertex from your points here, 2 and 4. So how about we go ahead and identify that vertex, since we need that to plot our point here. Now again, you have x minus 2, which tells you that h is a positive 2. This is negative 4. So of course your y or your k value is going to be negative 4. We said that the axis passes through the x coordinate of your vertex, so your axis is going to be x equals 2. And then we'll come back and talk about our domain and range after graphing this function. Okay, so again we need a T chart to help us out. Now we already have the vertex 2, negative 4, and we need only 2 more points to help us graph this function. So how about we use the number 0, and let's see what we end up with. 0 will give you 0 minus 2. So 0 minus 2 gives you negative 2. Negative 2 squared gives you 4. 4 2s are 8. 8 minus 4 will give us 4. Okay, we need one more point, but let's go ahead and graph these and see where each one of these points are going to be. So you have 0, 1, and 4. So 0, 4 will be a point right here. Your vertex is 2, negative 4. Now remember, your graph opens up, which tells us that the vertex is going to be the lowest point on your parabola. So 2, negative 4, this is 2, negative 4 is right here. So this is your vertex. So you can see we have 1 point here, 1 point here. So we need a point which is greater than 2 here. So how about we use the x equals 4, and that should give us a point on the other side of our vertex. So if I use 4 here, 4 minus 2 will of course give me 2. 2 squared is 4. 4 times 2 is 8. 8 minus 4 looks like I end up with 4 again. So that should be pretty good. 4 and 4 right over there. So looks like our graph should look something like this. Okay, and of course you can see that we had a horizontal shift by 2 units. Our graph has moved 2 units to the right. A vertical shift of negative 4, which means that our graph moved 4 units down. And since 2 was a positive number, you can see of course your graph opens up, but 2 is greater than 1. So you can see that your graph is narrower than what your x square graph would have been. Now that we have our graph, we can try and come up with our domain and range now. So of course you can see as these arms will grow, it covers all the values on the x-axis, which will be negative infinity to positive infinity. And for your range, you're starting at y equals negative 4 because that's your lowest point, and you're going up to positive infinity. So again, you don't have a graph below negative 4 value. You're starting at negative 4 and going to positive infinity, and that will be your range. Okay. Now let's say just for discussion, that if this were a negative number, then your graph would have opened down. Okay. And if this would have been, let's say, 2/3 or some kind of a proper fraction, that would tell us that the value is between 0 and 1, and in that case this graph would have been wider. Okay, but so try and work with different examples just to get a feel for what that coefficient will look like when it changes. And that basically takes care of section 11.6, and that is the end of chapter 11.